Hi everyone, today we will see about ISO 13485 is a quality management system standard specifically focused on medical device. Today we will understand why it is needed and how the major QMS activities connect from product development through post-market activities. The goal is to understand the flow and how each activity support product quality and regulatory compliance. We'll see what is ISO 13485. It is an international standard for quality management system for medical device, provides a framework for control, consistency and documented process. ISO 13485 gives medical device organizations a structured framework for that system. Then why do we need ISO 13485? The purpose is not just to find mistakes, it is to build a system that reduces the chance of mistakes happening. Give a simple example. An incorrect component can affect the device performance, so supplier production and inspection controls are needed. Then we'll see the difference of ISO 13485 and 9001. It's ISO 13485 is not simply ISO 9001 with a medical label. It is a tailored to the regulatory and product safety needs of medical device. We'll walk through the entire flow once before going to detail. Emphasize that these activities are connected, not isolated departments. Step 1, establish the QMS. Before controlling product, the organization needs a control system. Management set directions, responsibilities are assigned, and processes are documented and implemented. Step 2, understanding regulatory requirements. Regulatory requirements vary by market. ISO 13485 supports the organization's ability to meet applicable regulatory requirements. It does not replace the law of each country. Step 3, risk management. If a device can provide an incorrect measurement, the team identifies the hazard, evaluate the risk, add controls such as design, safeguard, or testing, and check that the control works. Step 4, design and development controls. In this, verification and validation is the most important role. Verification asks, did we build the design correctly against requirements? And validation asks, does the finished device meet the intended use and user needs? And step 5 is a supplier management in that will identify critical suppliers and outsource process and define supplier requirements and acceptance criteria. We'll see an example. A critical electronic component supplier may need qualification, define specification, incoming controls, and ongoing performance monitoring. The level of control should reflect the risk and impacts. Step 6, production and process control. The production must be reproducible and controlled. A finished product test alone may not be enough when a process can't be completely verified afterwards. Step 7, document and record control. It ensures documents are reviewed and approved before use. We'll see an example. If an operator uses an outdated work instruction, the process may be performed incorrectly. Document control helps ensure the correct approved version is used. Step 8 is training and competency. This identify competency requirement for each relevant role, provide appropriate training and or other actions. Here, that attendance alone is not always enough. The organization needs appropriate evidence that personnels are competent for assigned work. Step 9, complaints handling and post-market information. This receives and document complaints and product related feedbacks. The complaint reviewers may need to access the event description, attachments, available evidence, and reportability information. Stress that the exact regulatory report criteria depends on applicable market and procedure. 10th is non-conformity and COPPA. Here, the correction fixes the immediate problem. Corrective action addresses the cause of a detected non-conformity to prevent a recurrence. COPPA should be based on evidence and risk. Step 11 is internal audit. Internal audit is a health check of the QMS. Auditors should look for objective evidence rather than relying only on verbal confirmation. 12th is management review. The management review connects operational data to management decision. It is where leadership evaluates whether the QMS remains suitable, adequate, and effective. Step 13, continual improvement. This emphasizes that improvement is a cycle. Compliance, audit finding, supplier issue, CAPA, and process data can all provide inputs for improvement. This is end-to-end ISO 13485. The risk management is not a one-time activity. Information from production and post-market activities can feed back into risk evaluation and improvement. Next is real medical device example. We'll see the patient monitor. Use this example to connect the individual ISO 13485 activities. Avoid claiming that every patient monitors uses exactly these controls. This is a simplified illustrative example. This slide is specifically useful for complaint handling team. Explain that missing evidence, incomplete descriptions or overlooked attachments can affect the quality of the assessment. So define review steps and appropriate evidence checks are important. I am closing by summarizing this. ISO 13485 is a system for controlling quality and risk across the medical device lifecycle. And tell me which ISO 13485 process is most relevant to your role. Comment below. Thank you for watching.